Good morning, students. My name is Dr. Chinna Rao. I am working in Avanti Institute of Engineering and Technology as an associate professor in the Department of Mathematics. Today, I am going to explain truth tables, which is in discrete mathematics and graph theory. So, to learn truth tables, we have to learn these concepts. So, first of all, read 5 or 6 times and then understand and keep in your mind. So basically, we need conjunction, disjunction, and conditional by conditional statements, and it's a truth values. So P and Q is true when P true and Q true. Otherwise, it is false. When we have two variables, then we have four possibilities. So P and Q is true when both P and Q true, otherwise it is false. It means remaining other three cases. And P or Q is false when P false and Q false. Otherwise it is true. P conditional Q is false when P true and Q false. Otherwise it is true. P biconditional Q is true when both P and Q are true or both P and Q are false. It means P biconditional Q is true when P and Q have identical truth values. Okay. Construct the truth table of the compound proposition P implies negation Q R R. Here we have to observe that how many variables are there in this compound proposition. Here P, Q, R. So we have three variables, so that we have to take three variables. When you have three variables, then we have two cube combinations, that is eight combinations. So first you form eight combination, that is true, true, true. So there is a technique. First you fill PQ. That means true, 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 true. True, false, true, false. False, true, false, true. False, 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 false. After then, fill R. True, false, true, false, true, false, true, false. This is a technique you have to follow. After that, what we require to find, first you have to fill this bracket. That means we require to find negation Q. Here Q is true, negation Q is false. Here Q is true, negation Q is false. In the similar way, you have to find negation Q and then calculate negation Q R R. As per the definition, PRQ is false when both P and Q false. Otherwise, it is true. As per the definition, true or false, it is true. False, false, it is false. When both false, then only PRQ false. Otherwise, it is true. So, in the similar way, we write a negation Q R R. And then last column P conditional negation Q R R. So, take these two columns. As for the definition, P conditional Q is false when P true, Q false. So, P conditional Q is false when P true, Q false. Otherwise, it is true. Now, observe that false true. It is other case true. False false. It is sorry. You have to write P and negation Q are true, 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 false, false, true, true, true. We have to remember in this condition. When you have true, false, then only P condition Q is false, and otherwise it is true. In the similar way, we have to fill false, true. It is true. So simply keep in your mind in this box and fill this table. That's enough. This is known as a truth table. Okay, this is homework. Find whether the following is a tautology or not. To decide whether it is a tautology or not, first you have to form a truth table. That means, according to the definition, tautology, a compound proposition that is always true for all possible truth values of its variables. That means you have to form a truth table and then check its truth values. If all are true, then it is a tautology. If truth values all are false, then it is a contradiction. If the compound proposition contains some true, some false, then it is called contingency. Okay. So you have to keep in your mind these three definitions, then follow. Yes. Here we have three variables, so that you have to fill PQR. And then this bracket requires negation Q. Yes, calculate negation Q. And then negation Q R R. So last proposition, compound proposition is P conditional negation Q R R. Here we have to observe the compound proposition contains all truth values are true. So it is a tautology. If the compound proposition contains all are false, then it is called contradiction. Okay. Now prove that P conditional Q and R is equivalent P conditional Q and P conditional R. And this question may ask like this: P conditional Q and R and P conditional Q and P conditional R logically equivalent. The examiner will ask the question in both ways. So, to proving equivalence, you have to form truth table. So, you have to observe that how many variables involved this compound proposition. So, basically, three variables. So that you have to form 8 combinations. And then first you require to find this bracket Q and R. Okay. Again, required bracket is P conditional Q. First you have to form required brackets and then form remaining combinations. P conditional Q, P conditional R. And then complete the compound propositions P conditional Q and R, P conditional Q and PR. Finally, you say this column as A, this column as B, then A by conditional B. Okay. So, according to the definition, you write conjunction Q and R. Q and R is true only when q true and r true, otherwise it is false. True, true. Yes, true, true, true. True, false, false. False, true, false. You have to observe that when it contains true, true, then only it is true. Otherwise, it is false. And p conditional q definition is when p true, q false, then only p conditional q is false. And remaining cases, it is true. So, as per the definition, p is true and q is true, true. True, 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 false, then only false. When you observe true, false, p for true, q false, then only p conditional q is false. And remaining all cases, it is true. So, true, false is false, true, false is false, false, true is true. Because this is other case. And again, p conditional r. You check p with r. True, 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 false. What do you say? It is true, true, true. True, true, true. True, false is false. Okay, true, false is false. False, true, true. False, true, true. False, false, true. False, false. You have to keep in your mind. And again, P conditional R. P with R. True, true, true. True, false, false. True, true, true. So, in this way, you have to form A conditional, A biconditional B. That is, and we also observe that A and B have identical truth values. So it is a equivalent. Or you have to find A biconditional B. So biconditional definition is when P and Q have identical truth values, then it is true. True, true, true. False, false, true. False, false, true. So in this way we feel this. A biconditional B is a tautology. When the definition says A biconditional B is a tautology, then we say A is equivalent to B. Whenever we want to prove equivalence, you have to show A biconditional B is a tautology. When A biconditional B is a tautology, then we say A is equivalent to B. Okay. Here, prove that P conditional Q tautologically implies negation Q conditional negation P. So to proving tautologically imply when A is said to be tautologically implies to B, you have to prove A conditional B is a tautology. As for the definition, what it says? Tautologically imply. A statement A is said to be tautologically imply a statement B if A conditional B is a tautology and it denotes A implies B. So, to prove tautological imply, you have to prove A conditional B is a tautology. When A conditional B is a tautology, then we say A is tautological implies to B. So, yes. So, to proving this, P conditional Q conditional of negation Q conditional negation P is a tautology. If P conditional Q conditional of negation Q conditional negation P is a tautology, then we say that P conditional Q is tautological implies to negation Q conditional negation P. So here we observed that that compound propositions contain two variables. So in two variables we have a two square combination, that is four combination. First you write basic variables PQ, true, 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 false, false, true, false, false. First fill this, and then what we require, negation P, negation Q, first you find. According to the true, P true, negation P is false. True, false. When P is false, negation P is true. When P is false, negation P is true. Okay. So again, fill columns Q, negation Q, P conditional Q. As per definition, we know that P conditional Q is false when P true, Q false. And remaining cases it is true. That is true, 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 false, 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 true, true, false, false, true. The only thing is when P true, Q false, then only P conditional Q is false, and remaining all cases it is true. You keep in your mind, and every time revise a magical box. So again, negation Q, conditional, negation P. So you have to go through negation Q to negation P. So false, false, true, true, false, 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 true, 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 true. So now form the last column, that is given compound proposition. You have to form P conditional Q, conditional negation Q, conditional negation P. As per the definition, P conditional Q is false when P true, Q false. You have to remember true, 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 false, false, true, 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 true. Yes. And also observe that P conditional Q, negation Q, conditional negation P have identical truth values. Okay. Then after writing compound proposition, all it contains truth values. So it is a tautology. Then we conclude that P conditional Q tautologically implies to negation Q, conditional negation P. Prove that the proposition is a contradiction. So first you observe how many variables involved in this compound proposition. Yes, after observing, we note that it contains three basic variables. Those are P, Q, R. So that we have two cube combinations, 8 combinations. According to the previous method, you have to form. And finally, the last column, we observed that all truth values are false. When the compound proposition or given formula contains all are false, then it is called contradiction as per our magical box. So every time you remember more and more times. Without practice, it is not possible to remember. Take book and pen and practice. This is most important. Of course, these are all important. Obtain principal disjunctive normal form of P and Q, or negation P and R, or Q and R. So here we have two methods. One is a truth table method, other one is algebraical method. So here we are giving solution by truth table, right? To find principal disjunctive normal form, or PDNF, or PCNF, principal conjunctive normal form, or PCNF. To find whatever it may be, you have to form truth table. Basically, we have three variables, so that we have 8 combinations P, Q, R. According to the previous method, you have to construct truth table. After constructing truth table, you have to write min terms Additionally, what is midterms? Okay, how do you construct midterms? After finding compound proposition, this column you have to take truths and circulate. This is true, this is true, this is true, this is true. After truths, you have to circle. We have four truths: one, two, three, four. Okay, and then you have to write minterms. Minterms in the sense you have to take the combination of these variables also true. That is, take the conjunction and make it to be true. This combination is true when P, Q are both true. So P and Q and R. Okay. Next, this combination is true happened when P true, Q true are also to be true. So to make true, you have to change false into true. That means P and Q and negation are, because PQR is true happened when both PQ are true. Okay, then P and Q and negation are. That's why I wrote here P and Q. And this combination is true happened. P true, okay. This also have to true. That means you have to take negation of this. This is same. So P and negation Q and R is true. So this is true. P and negation Q and negation R. So whenever it contain false, you have to take negation, because conjunction of PQR is true only when PQR both true. So these are called mean terms. After that, to find PDNF, you have to take truths. This is a true. What is true here? P and Q and R. This one. And this. Take the min terms and write its disjunction. That is P and Q and R. Next, P and Q and negation R. Next, truth value contain this. R, negation P and Q and R, and this is negation P and negation Q and R. So PDNF says disjunction of min terms. Disjunction of min terms. Thank you very much.